This talk and the associated paper assume a particular approach to trust schemas, so I'll start by defining its general context and use home IoT as an example of that context. One of our goals is to put application communication needs at the center of developing its secure transport, and this work is progress in that direction. This work is focused on trust schemas that apply for a particular domain and have a single root of trust. Within that domain, the trust schema completely specifies who gets to say what to which, who will come from the signing identities, what is constrained by strictly defined names that can be legally signed by a particular signing chain, and a recipient uses those rules to know which data to accept. This analogy comes from an observation Van Jacobson made in his ICN when keynote in 2019. We can employ trust schemas like building plans to check the plans themselves, to build, and for an inspector to validate that building when it's done. This is a great idea, but a lot of work has to go into the tools and the methodology to implement the approach. A fully functional toolkit to go from trust schema rules to data-centric transport is available at this repo, but we have certainly learned as we've gone along and are still learning. There are some admittedly complex concepts here that cannot be explained in 15 minutes, but if you're interested, please see the paper or the repo examples. So looking at the left side of the slide, the first place we start is with the plans themselves, and we write them in a declarative schema specification language that we sometimes call the Versec language, and that goes into a text file. And then that text file is checked for soundness by a compiler, Schema compile. And this checking is quite extensive. It checks for language errors, but it also checks that the schema is internally consistent and that the components are properly defined, and that includes any certificates that are needed. There's verbose diagnostic output, and also you can just output a binary version of the trust schema. And that binary trust schema can be used by the library which creates a trust schema enabled transport, and it's the schema lib part of that library that reads that binary trust schema. But just some things to keep in mind here that might help keep you from getting confused is that messages are the things that go to the application, and we have this API that we call a shim. And then within that trust schema enabled transport, we use publications. So the messages get turned into publications, which are actually NDN data, but those are encapsulated within NDN data, which we call sync data, to go on the wire or the air or however you want to look at it. So home IoT is an exceptionally attractive use case for this approach, and these two characteristics of home IoT make it that so. In addition, home IoT is an accessible application because it's possible to work on a complete real system, unlike, say, industrial control of a power plant, which isn't something that just anyone can get a hold of. So if you look at the example of SmartThings, which is typical of these home IoT systems, we have capabilities that represent the functions of a device, like light, temperature, switch. Capabilities have specific commands and attributes that are the information they want to communicate about. And this example shows the layout of that for SmartThings. So this is great. We can use this to make sure that cameras and light bulbs don't issue commands and that switches can only issue very limited commands. An important principle for Versec and for DCT is what applications want to communicate about will be used to determine the publication names. And hopefully with more experience, this step might be made automatic or semi-automatic. For our example, we're using a shim. Recall, this is the API that's pretty general purpose. And our message-based publish, subscribe, MBPS for short, it's somewhat MQTT-like in its API. So then MBPS takes care of these non-bold components of the name, and the center portion is really what comes from the application. And in this case, that's the capability, the topic, which is the message type, the command, attribute, or event, and the location, which can have a broad interpretation. It's distinguishing which capability and topic we're dealing with, and it can indicate a room or floor of a building, a particular device or class of devices, a network, or it can say local to keep publications from going onto the network. And ARGS is just any additional information this topic requires. And I just want to note that in the trust schema, the lack of a leading underscore means something that the shim has to pass the contents to get this field set, and it's based on something that comes from the application. So this is the text version of the trust schema. Again, I can't cover every detail here, but there is documentation online and there's more information in the paper. So if we look at some of the main features, we can see a publication definition. This is called report, and it's laid out just as you would expect from the earlier slide. And it's telling us that we can have a switch cert, which is a capability cert where the capability is set to switch, or a light cert, which is a capability cert where the capability is set to light. And then we have another publication that is LS state for light switch state. And that is a report publication where the topic must be attribute, the arguments must be either on or off, and it has to be signed by either a switch cert or a light cert. And we can look below to see what a capability cert, how that is defined more specifically. So it's not, the order here that's important, right? It's that everything gets defined. Another important thing is the light tag command, and the thing that's nice about this is that it allows us to associate a light and a switch. We use that tag to say, okay, they both have to be sync, and that means that the sync switch is wanting to talk to the sync light. So we run this thing through the through Schema compiler, and this is what the output will look like. And these are just annotations to give you some idea of what each item here means. But this is totally diagnosing what's going on, and it also can be used to make a binary schema. So, okay, we have this, and what do we do with it next? So now we can see how to actually deploy the trust schema. We take that binary, we're going to take that binary trust schema, and we're going to use it to make an identity bundle. And what this is going to do is allow us to create a trust zone. And within that trust zone, the trust schema specifies the format of the communications and the signing certificates with signing chains that all terminate in the same trust anchor, as does the signature of the trust schema itself. So entities that use the same trust schema and they have associated legal signing certs are going to form a trust zone, and that zone remains secure without the need for a physical network isolation. We can have other things happening on the same network, and we don't have to worry about the security. So DCT provides some utilities to help us put together that identity bundle, and these are all in the repo. So you can make a local trust anchor with a command line command that looks like this. It tells us to use EDDSA for the signing, and we're going to call it house.root, and it starts as HouseNet. And then we make a binary trust schema by turning the binary, by getting binary from the trust schema, and then we make a cert from it by using schema cert. So we put it into that, and we say we want to sign it with house.root. Then we make a role cert for Alice. And this is simpler than making a device cert that has multiple capabilities, so it makes it easier example to show you here. And just notice that the Alice bundle has 3 certificates, and it includes her private signing key. And the way we know that we've included her private signing key is that plus. So these are just public certs, and this has the private signing key. And then we just start the app from the command line by handing her that bundle, and now Alice can join the trust zone. So this is what happens once the app with Identity Alice is started. This is all handled through the library, and the trust schema is used by SchemaLib to know what to do. So the app pubs will go through this SyncPS collection housenet/pubs, but there's also a related collection that gets made first, housenet/certs, and it uses a signing certificate distributor to make sure the other apps have all the certs in this app signing chain, and it has theirs. So that's what's happening on this side. And it stays in this state of listening, so if there are any more received, it will always try to validate them and add it to its collection. But once it's successfully published it, if we've specified content privacy through AEAD, it's going to kick off this group key distributor. And within the group key distributor, it's going to join the HouseNet key collection. If there's no data there, it's going to create a group key and become the key maker. Otherwise, it's going to find a copy of its group key in the data and decrypt it. Now it has the group key. It indicates back to the app we're connected to the zone and we're ready to communicate. And communications will be private. So things that I want you to note is that Alice has no a priori knowledge of the other entities in the trust zone, nor they of her. The application has no interaction with the certificate and key distribution. These are invoked by SchemaLib methods and based on whatever SIG managers are selected. If AEAD is specified, a sync data packet in the pub collection is discarded if it isn't AEAD signed with a known key. If EDDSA is specified, for a wire packet, a sync data packet in the pub is discarded if it isn't EDDSA signed by a known signer. For a pub, the publication is discarded if it isn't EDDSA signed by a known signer, that's the cryptographic validation, or if the signer's chain isn't consistent with the publication's name according to the schema, that's a structural validation. So here's some further work that we plan to do is more expressive VerSec and schema compile and more efficient broadcast communications on the wire or the air, that's in progress. Modules to distribute the trust zone geographically. Hierarchical and connected trust zones is on our radar, and there are other opportunities, we hope, for other people. We've made it easy to add SIG managers to do security research. An improved group key distributor would be a great idea. We would certainly welcome work in provisioning and online updates for trust schemas and distributing and updating signing certs. It's also possible to make shims for other communications models other than pub/sub, and also tools that would go from the rules to VerSec or tools to go from application communications to VerSec would all be useful. Okay, thank you.